If you've ever looked out the airplane window during a night flight, you might have noticed a faint red or orange glow inside the jet engine. It almost looks like the engine is burning, but don't worry, that warm light isn't fire, it's physics and engineering working together. Jet engines generate enormous heat by compressing and burning air mixed with fuel. Inside the combustion chamber, temperatures can exceed 1,500 degrees Celsius. Metal parts like turbine blades are glowing hot at those levels. However, special alloys and cooling techniques allow them to survive this intense environment without melting. At night, when sunlight and reflections disappear, that high-temperature glow becomes visible. The metal surfaces inside the exhaust area radiate light, just like a stove coil turning red. In daylight, you'd never see it, but in the dark, the contrast makes the faint red hue stand out clearly. That reddish color actually tells you something about temperature. According to the physics of blackbody radiation, objects around 800 to 1000 degrees Celsius emit visible red light. As temperature rises, the glow shifts toward orange and yellow. Engineers use this predictable pattern to estimate how hot engine components are running. In modern testing facilities, engineers use infrared sensors and thermal cameras to observe these glowing parts in real time. Each color gradient is analyzed frame by frame, helping them fine-tune airflow, material coatings, and cooling paths to balance performance and durability under extreme heat. Modern engines are so efficient that their combustion process burns almost perfectly. This means the light you see isn't flame escaping the engine, but the thermal radiation from hot metal and gases. In older engines, small bits of unburned fuel sometimes caused brief sparks, but modern designs eliminated that effect. The glow is most visible during takeoff or climb. When engines operate at maximum thrust, during cruise, power is reduced, airflow increases, and temperatures drop slightly, making the glow weaker or even invisible. Pilots can sometimes gauge engine health by noticing changes in this glow's brightness. Engineers design each turbine blade with hollow interiors and tiny cooling holes that bleed cooler air from the compressor stage. This film of air forms a protective layer, keeping the blade surface within safe limits even as the gas stream exceeds 1,400 degrees Celsius. It's a masterpiece of thermal control. At night, photographers sometimes capture long exposure shots of planes taking off, showing deep orange trails behind the engines. Those aren't flames, but heated exhaust gases mixing with cooler air, still glowing briefly before fading. It's one of aviation's most mesmerizing sights, beauty born from controlled combustion. Some viewers worry that a glowing engine means danger. In reality, that gentle red is a sign of normal operation. Jet engines are tested to extreme limits before certification. They must endure hours of sustained high temperature running without failure. What you're seeing is proof of precision, not peril. So next time you glance out the window and spot that dim red light, remember, you're witnessing the raw power of physics in motion. Beneath that glow lies decades of engineering, a balance of fire, air, and metal, propelling hundreds of tons of aircraft smoothly through the night sky. That's it for today's video. If you enjoyed exploring with me, don't forget to subscribe to Science Lab, where we turn everyday things into scientific discoveries. See you next time.